So our project goal is to find a fair price of a financial option, which is essentially a contract to buy a stock later by simulating the stock market's movement by a million amount of times. I'm going to go ahead and run this program. And what we're going to notice is that it's extremely slow. And this is the thing about Julia is that the first time you run a program, it's going to be extremely slow. And that's just the consequence of why it's so fast later on. You just need to get it going. So unlike Python, which interprets code line by line, Julia uses a just-in-time compiler. But because of this, once the functions are compiled, it stays in Julia's memory, and the second time you run it, it runs as nearly as fast or the same speed as C. So it returns how many CPU threads it's using, how long it took to simulate a call and put option, and it returns our call price, put price, and our graph. So our call price, or when to buy the stock, is $10.45, and we should sell it at $5.50 based off of the parameters we gave it. So we said that the initial stock price is $100, our strike price is $100, 5% risk rate, 20% volatility of how the market is moving over a year span of time, and a million simulations or what if scenarios. We can run it one more time and we can compare how fast it is compared to the first time it ran. So a lot faster, and it's slightly different outputs. We have $10.44 for the call price and $5.58 for the put price. And one thing to notice is that the outputs are slightly different. And this is because um, every time we hit run, we're running a million simulations, which again are basically a million what if scenarios, and different outputs are due to how the random number generator interacts with multi-threading. So although we do have a set um, parameter, it will give us different call prices and put prices based off of the random number generator. And here's our graph that it generated. We have the running average price in blue and the final price in red. So now we're going to go over our second version. And this version, we decided to allow the users to input whatever they wanted. So we can say $100, risk-free rate, and so this is a lot faster. Our call price with our inputs given, $39.30, and our put price is extremely low. And this is our graph for those inputs. The reason why it's so crazy in the beginning is because that's how many simulations it's going through. And if you do like 5 simulations, it's going to be like this because it's not getting enough simulations to determine what the price should be at. So we can run this one more time with different inputs. We can do inputs similar to the first program. So over a million simulations, and it should be very similar to what we got. Right. So our call price is $10.47, and our put price is $5.57. Essentially, what I wanted to do here is show how accurate it is compared to the first one. Very similar. So they're doing the same job. And this is our graph for this one. We can see again the running average in blue and the final price in red.